Hi grade 11s. This is our last lesson on solids, and today we're going to be having a look at spheres and cones. Remember that you can be asked to determine the volume or surface area of any solid, since you will always be given the formulae. Okay, let's first have a look at a sphere. Now a sphere is a three-dimensional object that is shaped like a ball. Okay, so there we've got a marble, here we've got the earth, and here we've got a soccer ball. Now every point on the surface is the same distance from the center. Okay, let's have a look at the two formulas for these. Okay, so your surface area of your sphere is 4 pi r squared. Remember, you do not have to learn these. And the volume is 4/3 pi r cubed. Okay, you can see how surface area, you're going to get a square unit. Volume, you're going to get your cubic unit. Now let's have a look at a cone. A cone, of course, is just a pyramid with a circular base. Okay, now when we have a cone, okay, here you've got your radius for your circular base that you've got. We've then got the height, which, remember, a height of a pyramid, which this is a special case of, goes from the vertex down to the middle over here, and it's perpendicular. Then we have what we call the slant height as well. Okay, now let me give you the formulas for these two. Okay, so the surface area of this is pi rh plus pi r squared. Okay, so pi r squared is your circle, that's for the bottom part, and your pi rh is for the curved surface that you've got over here. Okay, then your volume is 1/3 pi r squared times h. Okay, and h is your height, that height over there. Okay, let me do an example. You know, South Africa is a very dry country, and many places have got a water tank to store water in, and they get it off the roofs of their homes. Now here, this is a picture of a water tank, and it consists of a cylinder at the bottom. You can see the cylinder here, and then it's got a cone at the top. Okay, the diameter of this water tank is 1,6. Okay, so from there to there, that distance there is 1,6 meters. The height of the cylinder is 2,5 meters. Then we've got our cone over here. The top from the peak down to over here is 1 meter. Okay, so that distance there is 1 meter. What I'm going to do now is calculate what the capacity of this tank is. In other words, what the volume of this tank is. Now, let me take these dimensions and put them onto a diagram. Okay, so we know that this diameter, the diameter here is 1,6 meters. This height over here is 2,5 meters. And this slant height over here is 1 meter. Now, the formula that we've got to use is as follows. Okay, the volume is pi r squared h plus 1/3 pi r squared times capital H. Now remember, when they give you this formula, they're going to tell you what is what here. So this small h over here is the height of the cylinder, and the capital H is the height of the cone. Okay, so now let's have a look. We've got almost everything that we've got here. So this here is our little h. Our radius, this is our diameter. So in other words, our radius is going to be 0,8. Our problem is that we don't know what this height over here is. We don't know what the height from there to there is, and that over there is our capital H. But now if you have a look at this, what we've actually got here is a right angled triangle that looks like this. Okay, it looks like this, and what we've got is this dimension over here. This is 1,6 from side to side, that's your diameter. In other words, one of these is 0,8. We know that the slant height is 1 meter. This is also in meters. And we know that this height is perpendicular, which means that we can find this height over here using Pythagoras. Okay, so let's start by doing that. Okay, so your h squared plus your 0,8 squared is equal to 1 squared. Always start with your Pythagoras in this format here. So your h squared is 0,8 squared, I know is 0,64, and 1 squared is 1. So to find h squared, we've got to take the 0,64 to the other side and make it minus. So 1 minus that gives you 0,36. We then have to square root both sides, and then h is then the square root of this, which is 0,6 meters. Okay, so if we go to our diagram, we can now go and put on here, and we say, right, this thing over here is 0,6 meters. Okay, so we've got all our values now, so we can now substitute into our formula. Okay, so let's do that. Okay, so it's going to be pi. Our radius is 0,8. Remember, it's half of the diameter, and the height of the cylinder is 2,5. And then this is 1/3 pi. Our radius is also 0,8, and this height is 0,6. Okay, so now we can just put that into the calculator and do it in one calculation. Okay, so it's going to be pi times 0.8 squared times 2.5, and to that we're going to add 1/3, let's do it on the fraction there, and we're going to multiply that by pi, and the radius is still 0.8, we've got to square it as well, we've got to multiply by the height of the cone, which is 0.6. Okay, so that gives you 5,428. Okay, so it's 5,428, and this is of course cubic meters. And since they haven't told us what to round off to, we're going to go to our default, which is 2 decimal places. So this is going to be 5,43 cubic meters. And you're going to be working with the same water tank that we've just been dealing with. Okay, so the water tank has got a cylinder that's 2,5 meters high, got a diameter of 1,6 meters, it's got a cone at the top that's got a slant height of 1 meter. Okay, now I want to know what area of material has been used to make this particular water tank. So I'm going to give you the formula for the total surface area as you would be given. So it's pi r squared plus 2 pi r h plus pi r s, where s is equal to your slant height. Okay, so you've got to get all the stuff off the diagram and substitute them into that formula.